Okay, let's dive right into this explainer. We're looking at a fascinating piece of history today where high-tech military engineering smashes right into everyday scrappy ingenuity. It's a seriously unexpected chain of events, and yeah, pun absolutely intended there. We're going to see how a massive global crisis forced a total reimagining of how we build things, and how it literally led to one of the most common household appliances you probably use every single day. So, what does a painstaking lathe setup, a Sears bicycle chain, and a melted chocolate bar all have in common? I know, it sounds exactly like the setup to a weird joke, right? On the surface, absolutely nothing. But as we unpack the source material today, we're going to find out how these completely unrelated things collided during World War II. They didn't just alter military history, they completely changed our modern kitchens forever. Section 1. The Art of Machining, Precision in Metalwork. To really grasp the magnitude of the breakthrough we're talking about, we first have to appreciate the slow, incredibly exacting art of traditional precision metalwork. Think about a classic 9-inch South Bend lathe with a tool height fixture. When a machinist is turning metal, especially with a really delicate cutoff tool that's under 0.2 inches in diameter, there is zero margin for error. The tool bit height has to be absolutely dead on. You can't just eyeball it. And this brilliantly illustrates just how methodical the whole process is. First, you mount a custom notched aluminum fixture to the lathe bed. Then, you place a live center in the tailstock just to calibrate your vertical height. Finally, you carefully adjust the tool bit so the tip rests exactly at the top of that notch. You have to go through all of this custom fixturing and perfect calibration just to make sure the dial on your crossfeed gives you a truly accurate reading before you even think about cutting metal. And it's not just the cutting tools either. Just look at all the intricate pieces of an Atlas 7-inch rotary indexer. Whether you're carefully setting up that tool height fixture or assembling a highly precise rotary indexer, traditional machining demands meticulous, unhurried perfection. It's really a beautiful, slow art form where master craftsmen take their time to get dimensions exact, right down to the thousandth of an inch. Section 2. The World War II radar bottleneck, a crucial production crisis. Now, hold on to that image of the slow, methodical machinist for a second. Imagine trying to apply that exact same unhurried process to mass-produce a life-saving military machine right in the middle of a global war. Well, that was the exact nightmare scenario facing the Allies. The British had invented this device called the Magnetron. It was incredibly complex, highly precise, and absolutely crucial for radar, which they desperately needed to win the war. But there was a massive bottleneck. They figured out that even if they took every single machinist in the entire country and had them work on nothing but magnetrons full-time, they'd only be able to produce a measly 10,000 units a year. And that was nowhere near enough. Enter our unlikely protagonist, Percy Spencer. Percy was definitely not your typical Ivy League engineer. In fact, he only had a formal grade school education. But whatever he lacked in classroom time, he more than made up for with this scrappy, hands-on mechanical genius. He'd been a machine shop hand, did a spell in the U.S. Navy, and once even successfully electrified a whole pulp and paper mill. That real-world, roll-up-your-sleeves experience made him the absolute perfect fit to join a brand new company called Raytheon, actually serving on their original 3-man staff. Since the British just couldn't manufacture the magnetron at scale, they brought it over to America, specifically to Raytheon. And when they presented this wildly complex, top-secret device, Percy did something just incredible. He casually asked the British scientist, J.D. Cockcroft, if he could just take the top-secret magnetron home for the weekend. And amazingly, Cockcroft actually said yes. Seriously, a guy with a grade school education just tucking the most highly classified piece of military hardware under his arm for the weekend. But sure enough, by Monday morning, Percy Spencer came back with a radical plan. Section 3. An unorthodox engineering solution, breaking the rules of production. So the crucial takeaway here is how Percy decided to tackle this problem. He immediately realized the bottleneck was the traditional machining itself. To win the war, he decided to just bypass those painstaking methods entirely. And this is really where his genius shines. The British method meant machining these complex shapes out of solid blocks of metal by hand, as we established that maxes out at 10,000 a year. But Spencer's method, totally different. He proposed stamping out thin sheets of metal, called laminations, stacking them up in the right sequence, and then running the whole thing through a continuous hydrogen oven to silver solder them together into a solid piece. Instead of carving away metal piece by piece, he was basically printing and baking them in a continuous, high-speed line. Well, when Raytheon pitched this plan to the government and industry experts, they were basically laughed out of the room. The experts called it totally impractical. But Raytheon's general manager believed in Percy's ideas so fiercely that he told his company treasurer to secure the funding by any means necessary, stall creditors, cut corners, whatever it takes, just get the equipment. And when the treasurer protested, the manager literally pointed to a copy of the children's book, The Little Engine That Could, for inspiration. They decided to just build it themselves, on their own dime, to prove it could work. It's delightfully absurd, but guess what? It worked. Though it did create some major culture shock. In 1942, Navy Captain Henry Bernstein, the officer in charge of radar design, came down to tour Raytheon's facilities. He was fully expecting these pristine, state-of-the-art traditional machining labs. Instead, he was absolutely thunderstruck. He found that the Magnetron lathes had been built by Raytheon out of scrap parts, including literal bicycle chains they just purchased down the street at Sears. At first, he was totally horrified. Top secret, war-winning military equipment was being churned out using Sears bicycle chains. But you couldn't argue with the results. Percy's highly unorthodox, scrappy setup worked so flawlessly that they started churning out magnetrons at an unprecedented rate. Actually, they were making them so fast they nearly ran out of materials. When Percy told Captain Bernstein that production was about to grind to a halt because a supplier wouldn't ship their last order of oxygen-free copper, that same Navy captain personally forced the supplier to fill the order. The guy who couldn't believe they were using bicycle chains was now actively bullying suppliers to keep the bicycle chain factory running. That scrappy little setup literally saved the radar program. Section 4. The Accidental Microwave, a Sweet Discovery. Okay, let's see how this incredible mass production triumph leads to a total accidental consumer revolution. Throughout the 1940s, we saw massive production of these radar magnetrons, all thanks to Percy's bicycle chain setup. By the mid-1940s, he was playing a key role in designing proximity fuses to blunt the attack of Nazi buzz bombs. He was working directly with this super powerful radar technology every single day. And then came the fateful moment. While standing near some active high-power microwave radiation, Percy noticed something weird. A chocolate bar he had tucked away in his pocket had completely melted. Now, a traditional scientist might have just been annoyed about ruining their pants, but Percy's practical mechanical mind immediately saw a real-world application. That single melted piece of chocolate birthed the entire concept of the microwave oven. Percy realized that this radar radiation could actually be harnessed to rapidly agitate water molecules and heat up food. He took a piece of technology meant to spot enemy bombers and completely repurposed it into the ultimate kitchen appliance, revolutionizing how the modern world prepares meals. It's beautifully summarized in the historical retrospective we've been going through today. Percy Spencer was an American original. We shall not soon see his like again. He proved without a shadow of a doubt that a formal, traditional education is definitely not the only path to genius. Sometimes having an intimate, hands-on knowledge of how things actually work and being totally willing to break the established rules is what truly changes the world. So, as we wrap up this explainer, I want to leave you with a thought. The next time you effortlessly heat up your leftovers in the microwave, ask yourself, what major bottlenecks in our world today are being held up by quote-unquote traditional thinking? What modern impossibilities are just waiting for a completely unorthodox, scrappy Sears bicycle chain solution? Keep learning, keep questioning, and keep looking out for those unconventional answers.